how are you all? I hope you guys are good. So दोस्तों today topic is all about Terraform state management and remote backends, right? And the next topic is working with Terraform workspace and environments, right? But before we get started, if you have not already, make sure to hit that subscribe button and the notification bell so you never miss any of my future videos, right? Now let's jump right into Terraform state management and remote backends. So if you don't know what is how to create and manage basic infrastructure resources in Terraform, right? And managing infrastructure with Terraform. So now let's jump right into Terraform state management and remote backends. So basically Terraform state management is a critical aspect of using Terraform effectively, and state files track the current state of your infrastructure including resource, metadata, relationship and dependencies. By default, Terraform stores the state locally, but using remote backends allow for collaborative and secured state management. So here an explanation with a real-time example, like when you run Terraform apply, Terraform generates a state file that represents the infrastructure it created or updated. Get it? So this state file is essential for Terraform to understand the current state and determine any changes needed for subsequent runs. And by default, Terraform stores this state locally in a file called terraform.tf state. Get it? So however, managing state files locally can lead to challenges in a collaborative environment or when working with a team. In such cases, it's beneficial to use remote backends which store the state remotely, right, and provides additional feature like state locking and versioning. So one popular remote backend option is Amazon S3, which can store Terraform state files securely. So let's look at an example configuration that uses the S3 remote backend, right? So first I'm explaining this, right? So basically I'm explaining this block, Terraform backend configuration, basically this block, right? So दोस्तों, basically this block specifies the backend configuration for storing the Terraform state, and in this case it uses Amazon S3 as the backend with the following setting, right? First is bucket, right? So basically the name of S3 bucket where the Terraform start will be stored. Get it? Next one is key. So basically the file name of the Terraform state file within the bucket. Third one is reason. So basically the AWS reason, Amazon Web Service reason, right, where the S3 bucket is located. Fourth one is encrypt, right. So basically specifies whether the Terraform state should be encrypted at rest. Get it? So last one is DynamoDB table. So basically this is optional, right? So basically the name of the DynamoDB table to use for state locking and consistency checking. It helps prevent concurrent modification of the to the state. Get it? So next block is provide configuration, right? So basically this block configures the AWS providers for Terraform, specifying the region where the AWS resources will be provisioned, and in this case it sets to US2, right? Basically US West Oregon. Get it? Third block is define an AWS EC2 instance, right? Basically this block. So basically this block here is basically this block define an AWS EC2 instance resource named web server, and it specifies the Amazon machine image AMI ID, instance type and the key pair to use for SSH access to the instance. Get it? So next one is define a security group for inbound traffic. Basically, last point, right? So basically, this block defines an AWS security group resource named web server SG, right? It means SG, it means security group, and it allows inbound traffic on port 80. 80 is used for HTTP from any IP address, right? And basically, this block Terraform configuration will provision an AWS EC2 instance with a specific AMI instance type and security group, allowing inbound HTTP traffic on port 80, and the state of the infrastructure will be stored in an S3 bucket with encryption and optional by dynamicity table for state locking, right? So, here, right, in this example we have added a backend configuration block that specifies the S3 backend, and the bucket parameter determines the S3 bucket where the state will be stored, and the key parameter specifies the name of the state file within the bucket, and the region parameter specifies the AWS region where the S3 bucket is located, right? So we have also include the DynamoDB table parameter which enables state locking using an Amazon DynamoDB table, and state locking prevents concurrent Terraform operations for modifying the state simultaneously, ensuring consistency and avoiding conflicts. Got it? So basically this is optional, right? To use the S3 backend, you need to initialize Terraform by running Terraform init. It means initialize. Terraform will create the necessary resource including the S3 bucket and DynamoDB table. Now, when you run Terraform apply, so Terraform will store the state file in the specified S3 bucket, and this allows your team to access and manage the state file collectively. Each team member can run Terraform init to download the current state and perform operations accordingly, right? Using remote backends not only enables collaboration but also provides benefits like versioning and improved security. So it ensures that it ensures that the state is stored in a durable and centralized location, reducing the risk of accidental deletion and or loss. Get it? So next one is working with Terraform workspace and environment. So Terraform workspace and environments are useful feature for managing multiple instances on same infrastructure with different configuration or in different environments. So this is very important, right? So workspace allow you to maintain separate state files separate state files for each instance, enabling isolation and easy switching between configuration. So let's dive into an example to understand how to work with Terraform workspace and environments. Get it? Suppose you have a web application infrastructure that you want to deploy in two environments. First is staging and second one is production. Get it? So each environment has its own configuration such as variable values or resource setting, right? So to get started, you can create two separate directories, right? One for each environment. Let's call them staging and production. So within each directory, you would have the Terraform configuration file such as main.tf that defines the resources specifies to that environment. So here an example directory structure for clarity, right? So basically first is for staging area, this file main.tf, second one is production, and there is another file main.tf, right? So within the staging directory, you could have a main.tf file with the following configuration. First is provider configuration. Basically provider is AWS, reason is this, and next one is define an AWS EC2 instance for staging, right? So this file is written for staging, right? So basically resource is AWS instance, web server, AMI ID is this, instance type is this, and key name is this, right? So basically similarly the production main.tf file would contain the configuration for the production environment, right? So now to manage these environments using Terraform workspace, you can switch the appropriate directory and create a workspace for each environment, right? So first switch to the staging directory. You use cd and then staging, and then second one is initializing the Terraform configuration. So you use Terraform init, right? Third one is create a workspace for staging. So you use Terraform workspace new staging. Get it? So repeat the same step for the production environment. This is basically used for staging environments, and next one is production environments, right? So switch the production directory. So you use cd, change directory production, initialize the Terraform configuration, so Terraform init, and third one is create a workspace for production, so Terraform workspace new production. So Terraform will create state files for each workspace. So this allows you to manage the environments independently and switch between them easily. So to switch between workspace, you can use the Terraform workspace select command and switch to the staging workspace. So you use Terraform workspace select staging, and you switch for production. So Terraform workspace select production. Get it? So when you run Terraform apply, so Terraform will only apply changes to the infrastructure resources within the selected workspace. Get it? So using workspace and environment provider clear separation between different instances of your infrastructure, enabling you to manage them individually while keeping the configuration and state files organized. So it also makes it easier to promote changes from staging to production by applying modification only to the appropriate workspace. So note that workspace should be used for managing distinct instance of the same infrastructure configuration, not for different configuration altogether, right? So for managing uh, different configuration, you may consider using separate Git branches or directories, right? So thank you all for watching this video. To quickly recap, we discussed in this video is working the Terraform workspace and environments, and Terraform state management and remote backends, right? So hopefully you find the information useful and learn something new. If you have any questions or would you like to share your thoughts, please leave a comment below. Don't forget to like this video and subscribe to our channel for more content like this. We appreciate your support and look forward to seeing you in the next video. Take care and have a fantastic day.